Okay, so on this one, again, we're looking at integration and we want to locate the centroid of the shaded area. But instead of just doing X bar, let's actually find X bar and Y bar. Okay, so that would be truly where the centroid in terms of both the X direction and the Y direction is going to occur. Okay, so the first thing we need to do is figure out which way we want to integrate. And I'm going to note that if I come through here, then I'm at 1, at 2, and if I make my little box in this direction, then I can integrate from 1 to 2 quite easily. And I don't have to do anything extra or weird, like draw boxes and subtract or anything. So let's make our rectangle. And we find a centroid. And I'm going to integrate with respect to X. That'll be my differential element. So this is Y tall. And I know that Y tilde, okay, Y tilde is Y over 2. And X is going from the Y-axis straight up. So really, you know, on an exam, on the homework, you probably need to just go ahead and draw this again yourself. So let's just do that really quick. And we are going from 1 to 2, and we are going in this direction. So I have a dx, I have x, it is y tall, we have a y tilde equals y over 2, x tilde equals x. Our area equals y dx, and our curve is y equals x squared. Okay, and we know that if we're finding x bar, it's x tilde dA divided by dA, and y bar is y tilde dA divided by dA. Okay, so let's start with x bar. We have everything defined. We have a new figure drawn. There's our figure. We have y tilde, x tilde, dx, and our curve. So we have everything identified. We've defined y tilde and x tilde in terms of x and y. And we have dA. It is also defined. And we know if we're integrating with respect to x, we need to get rid of our y's, and I know that y equals x squared, so I have an x squared over 2. And when I look at my area, I have, okay, y is x squared dx. Okay, so everything is now defined in x, everything on my picture is defined. So x bar equals x tilde dA divided by dA. And we can now just come over to where we have everything defined. And I'm going to have from, remember I'm going from 1 to 2, x dA is x squared dx divided by from 1 to 2, x squared dx. So we're going to get 1 to 2 x cubed dx divided by from 1 to 2 x squared dx. And as I integrate, I'm going to get x to the 4th over 4 from 1 to 2 divided by x cubed over 3 from 1 to 2. I don't know why I'm still trying to add integration signs, but we don't need that because we just integrated. So this is going to be, you ready for this? 1 over 4 times 2 to the 4th minus 1 to the 4th. Divided by 1/3, and then I'm going to have 2 cubed minus 1 cubed. Okay. It was just easier. It's just easier if I can pull out those constants, that 1/4 and 1/3. So I now have 1/4. Okay, 2 to the 4th is 2 times 2 is 4 times 2 is 8 times 2 is 16 minus 1 divided by 1/3. 2 times 2 is 4 times 2 is 8 minus 1, which gives me 15 divided by 4 over 8 divided by 3. And then when I simplify that out, I get that x bar equals 1.6 inches. Everything was positive, so it is going to the right. And now I can do the same thing, but this time we're going to set up and we're going to find y bar. So y bar equals y tilde dA divided by dA. And I can go back over to my little figure in my variable definitions over here. If I have a y tilde, it is x squared over 2. So from 1 to 2, x squared over 2 times x squared dx. And then I have 1 to 2, and I'm still at x squared dx on the bottom for my area. Okay? So I'm going to pull this 1/2 out, and then I'm going to multiply x to the 4th dx divided by x squared dx. So I have 1/2 times x to the 5th over 5 from 1 to 2, and I'm going to have x cubed over 3 from 1 to 2. And again, I'm going to pull out all of my constants. So I have 1/10 times 2 to the 5th minus 1 to the 5th divided by, pull that 1/3 out, and I have 2 to the 3rd minus 1 to the 3rd. Okay? So I'm going to have 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I have 1/10, 32 minus 1, divided by 1/3, 8 minus 1, okay, because I had that from up above. So I'm going to have 31 divided by 10, which is, and then divided by 8/3. And when I simplify this out, I get that y bar is 1.33 inches. Y bar is going up. Everything was positive. My area is above. If we had a axis that was in the middle of my grade area, then we might have a negative. Okay, so like if I had my axis going through here instead of down here below, I might end up with a negative value, and that's fine. It's just showing us direction. So if we go back and look, we're going to be going over 1.6, which is, if this is 5, about here. Okay, there's my 6, and then 1.3. So if this is 1, it's going to be about here. So the centroid we got is about in that area, and that's probably higher than I would think it was if I was just guessing, but mathematically that's the way it works out. So there you have it. X bar is 1.6 and y bar is 1.33.